I appreciate you joining me. If you want to just kind of introduce yourself for everybody that doesn't know you as well as I do.
My name is Patrick Fiore. I'm the general manager of the HVAC division for all weather contractors here in Jacksonville, Florida.
Awesome. Yeah, I mean, Pat is kind of known in this market as our kind of go-to HVAC guru. You've been
do my best.
Well, I mean, you teach probably all of, if not most of, our HVAC classes here at the association. I know you've been around for quite some time, because even when I was starting in the industry as a tech, I mean, you were our kind of speed dial contact when we had an HVAC problem. You started in the industry too, didn't you?
I did. After not retiring, but finishing my career in the Navy, I took my first job with a property management company, specifically to handle their HVAC needs. That's what they hired me for. And of course, being a maintenance supervisor meant that I also had to do plumbing and roofing and carpentry and all sorts of things that I am probably not as good at doing. But I enjoyed my experience in the industry. I found that I was never looking for a job. People are always looking to hire somebody who knows what they're doing, at least for one of the disciplines, whether it be carpentry or plumbing or roofing or HVAC. So, yeah, and then eventually it got to the point that all I did was HVAC for a private ownership group in Tampa, Florida. And from that, then it progressed to, I had to become a contractor, because that's really all I was going to do. And for my career path, that's really where I wanted to go. As much as I like property management, all the other peripheral things that go on with that, which it's a big industry, was more than I needed to be, when really all I wanted to do was concentrate on air conditioning. So,
sure.
So here I am, 20 years later, as an air conditioning contractor, and we're across the Southeast. We're everywhere. And we're very blessed and fortunate to be as busy as we are.
Yeah. I mean, it's like I said, you're the go-to for most of us in the area, definitely for the association. And so, we certainly appreciate that.
I always appreciated working with other business partners in the industry that, helped us get our jobs done and advanced our careers, because not everybody's an air conditioning specialist. Not everybody's, again, a plumbing specialist, so definitely the industry relies on good business partners to help out. This change that's coming here, this SEER 2 rating, which is Greek to many people, and the A2L refrigerant, these things are coming one after the other. But to jump into this, the SEER 2 rating is something that comes from the Department of Energy. So when we say DOE, that's what we're speaking about, it's the Department of Energy. The A2L refrigerant, that really comes from the EPA, so the Environmental Protection Agency. That's two different things, but they both have a lot to do with air conditioning and regulating air conditioning because of efficiencies and because of the refrigerants used to do air conditioning work. Starting off, the SEER 2 rating is complicated and confusing to people. That stands for Seasonal Energy Efficiency Ratio. So most people are used to hearing 14 SEER, because that is our current minimum standard here in the South. Yeah. As long as I've been doing this, I remember working with 8 SEER equipment.
So I'm not quite there, but I remember 10 SEER.
Right. And so every 4 or 5 years, the federal government, the DOE, would say, well, air conditioner needs to be more efficient because we don't want to build more power plants. We want you to use less energy. And so we're going to make a minimum for you that is higher than what it is. And unfortunately, in the end, everybody's budget, whether it's a business or a homeowner, is going to take a hit. The more efficient the equipment, the more the regulations, the more money it's going to cost everybody.
Always, yeah. I mean, I think we all, most people remember the change from 13 to 14 SEER. I mean, that was significant in cost, and it was a refrigerant change as well. And yeah, so I mean, it's the more we talk to people in the industry, some are aware that this change is coming, some aren't aware at all. And some kind of confuse, there's kind of 3 changes that are going to happen one after another, but they are separate. So the first thing we want to talk about is the shift from 14 SEER to 14.3 SEER 2.
Correct. So it's a double whammy, which is what happened to the industry in the late 90s, early 2000s, shifting away from R22 to currently 410A, and of course there are many other refrigerants that were in play. The same thing's going to be true again. First and foremost is the SEER rating change, because that happens January 1st, 2023. As of that time, in the South region, which is where we're at, heat pumps with a rating of less than the SEER 2 rating of 14.3, which I'll talk about that in just a moment, will be banned from installation. You could still purchase them as long as they're manufactured, but you cannot install the straight cool version past January 1st. Yet a heat pump could be installed. So they've made this very difficult.
So the country's still broken into 2 or 3 regions.
3 regions, yeah. North, southeast, southwest, and all the regions have their own twists on this. And how it goes is, if you bought a gas furnace, which you use very little of here in Florida, in the South in general, but say Atlanta, yeah, there's a fair amount of gas furnace. You could install an 80% efficient gas furnace there, but you could not in New York do the same thing. You would have to use a 90% gas furnace. So different ratings on the gas furnace. Obviously, we're going to concentrate on the heat pumps and the straight cool systems, because that's what we deal with as a majority here.
Yeah, I think that's most common. And then I'll post links to some of these charts and graphs. I'll put some of them up in post-production as well. So those of you watching the video on Spotify or on YouTube will be able to see that. And at the very least, we'll have the links to some of this. Just know that there are different requirements in the different regions. Being in Florida, I think we'll talk a lot about that type of equipment.
Absolutely. So the southeast region goes all the way out to Texas, and it goes all the way up into Delaware. Believe it or not, Virginia is in the southeast region. Kentucky, Kentucky, I guess, more natural for that, but like I said, all the way up to Delaware.
Well, and so one of the key differences there that you already touched on is that, basically on that date, January 1st of 2023, in this South region, you could install a heat pump that you had already purchased, but you cannot purchase a new one in 2023. And when it comes to straight cool, you could not purchase or install that in 2023.
That's correct. And the majority of the manufacturers that we deal with have already started to curtail their shipments of the SEER 14, the original SEER 14 equipment. Actually, beginning of August, Carrier, who's one of the manufacturers we deal with, they're not sending any more into the South. They're done. It's not coming here anymore. It'll go up north where they can still use it. But ultimately, what's going to happen up north is they'll end up with the higher rated SEER 2 equipment as well, because the manufacturers don't want to have separate lines for multiple products. It costs them too much money. So we're seeing this. So will there be a lull and a shortage of product? It's quite possible. We already have that problem now with the supply chain. This may exacerbate that further.
So some of the listeners may already be struggling to find, 2-ton heat pumps or 2-ton straight cools or something like that because of this shift in equipment.
This is going to compound the problem. But what this is based on is the SEER rating is the government, the DOE, will have the manufacturers go to the AHRI, which will rate the equipment. And the manufacturers have to pay for this. They pay for the testing. The testing used to be that the equipment was run at full capacity with a static pressure of basically a 0.01, which is almost nothing, almost no ductwork on it.
Yeah, so the static pressure is basically how much resistance there is when the AC sucks air in, roughly.
When it's pulling it in and pushing in, the total static would be the resistance on the return side as well as the supply side. So setting an air handler in this room and turning it on and letting it run, or like the air handler next door in the training room, okay, that's running about how they did their SEER ratings. The government said that's not realistic, which they're right, it really isn't realistic to the real world. So the new SEER 2 means that the equipment will be tested at a static pressure of 0.5.
So they tried to compensate for dirty coils, dirty filter.
And ductwork in general, especially in homes these days and apartments where flex duct is the order of the day for many reasons, which could be a whole nother podcast on ductwork. But realistically, that ductwork has a lot of resistance to it. It just does, and it's not always installed correctly. But that resistance is real world, so they've taken the testing and moved it to that. The confusing thing is that now what you would say is a 14 SEER is not going to be the same as what is a 14.3 SEER 2. Today's 15 SEER would be more akin to a new SEER 2 rating of 14.3. So know that SEER 2 rating is all anybody will be talking about past January, probably really starting next month when these shipments from the manufacturer start hitting the marketplace. You're going to go do your permitting, and of course, fortunately the city of Jacksonville seems to be up on this, and they'll know that, okay, minimum rating. And how this goes, if you are indeed caught installing 14 SEER equipment in a straight cool after January 1st, you will be you could be fined heavily, and second, you're put on a do not sell list. You'll be blackballed from buying equipment.
Well, yeah, my understanding is the manufacturers won't honor warranties at that.
Oh, no, absolutely not. There's all kinds of things that go out the window. So nobody's going to really circumvent this and get around it, short of if you got a project now and you can get the equipment and get installed before the first, or if it's in the case of a heat pump, great, buy the equipment now, go for it. So we're running into this problem with new construction where a project's already going. It's getting straight cool units at 14 SEER. The project isn't going to complete till April of next year. So their budget is now going to change because the last 35 apartments or whatever it is they're going to build are going to have to be SEER 2 rated equipment.
And I know this changes from manufacturer to manufacturer and suppliers and all that, but is there like a rough idea of the cost difference? I've heard 20%. I don't know how accurate that is.
It's been hard to nail down only because every month since the beginning of the year, there's been a cost escalation, or every 2 months there's been a cost escalation on equipment. The price of copper was through the roof. Price of copper normally follows the price of fuel. At this point, the price of copper has actually dropped off, and yes, the fuel dropped off. Hopefully it's permanently. Doubtful, maybe it's temporary, we don't know. So these commodities affect the manufacturers, especially in the case of copper and aluminum, two items, and then steel that they use tons of.
So right now it's raw material that's driving the cost increases we've seen.
It is, and to reach more efficiency, you need more coil surface and you need more efficient motors. Those are the only ways to make a system more efficient, and that means more material is expended in a piece of equipment. As we saw back 10 years ago when they made the change, the units suddenly got bigger physically. The outdoor units got larger. And you'll see a little bit of that again, although a lot of manufacturers are really working hard to keep the same footprint, because in the apartment industry, especially with a wall-hung fan coil or a ceiling-mounted fan coil, there's only so much room. And there's only so much room that the architects and developers are willing to give up on floor space, because it all goes about livable square footage. So the manufacturers have gone out of their way to keep that indoor unit very close to the same size, which means where's that increase come from? It's got to be coming from the outdoor unit. And you also have what's called the FER rating, which is FER. It's a fan efficiency rating. That is another new thing that nobody really talks about because it's already happened and it's already inside the equipment. It's not a separate rating the consumer sees, but it's got to do with the efficiency of the fan motor.
So, and we see it a lot in heat pumps, that kind of computerized fan motor, the one that's like $500 to replace.
Yes. So you're talking about an ECM motor, which could be communicating or non-communicating. The communicating motors are the most expensive, wholesale price of like $1,200.
Wow.
Non-communicating ECM motors, like I said, $400, $500, $600.
And so that's going to be kind of commonplace in all equipment now?
It's going to be in almost everything you see, because they won't be able to meet these ratings without that. That is part of what is driving this. Now you're testing the equipment under a load. So that regular PSC motor that we used to with the capacitor for years and years and years, hey, it's very efficient when it's not actually pushing air against any ductwork. That's not the case now. They're going to test this thing under a load, so that ECM motor is going to become even more commonplace, whether people like it or not.
One of the things we saw with some of the SEER changes in the past is line set changes, bigger line sets. Do you know if that's something that's largely changing here?
At this point, the line set for most manufacturers, and this is where you have to be very careful, because the suction line, you can get away with actually a smaller suction line. It will take some of your efficiency and capacity. It's the liquid line side that we ran into with 410A. You had some units that ran on a old 5/16 or a 1/4 inch instead of a 3/8. Up until about 2.5 tons or so, you could almost get away with it. But after that, it wasn't a large enough column of liquid for the unit to actually run, because it required more refrigerant in the case of 410A.
Gotcha. We see that a lot with like third-story units too, struggle.
So the A2L refrigerant, which we'll talk about here in a few minutes, is where this may or may not be an issue.
Okay.
When we talk line size.
So in the 14 SEER to the 14.3 SEER 2, more than likely we're not going to see major line set changes.
No. Your manufacturers, for the most part, if your unit came with a 5/8, 3/8, it's still going to come with a 5/8, 3/8.
So there you go. We found the one good thing in this change. So the other piece of that, though, when we changed from the R22 to the 410A, there was a massive pressure change. Because these new 14.3 still run on 410A, then that shouldn't be a factor here either.
No change service-wise. The A2L will be the change we'll see on that, but no change. And before I do forget to mention, with SEER 2, that rating goes up to 45,000 BTUs. So we're talking 3.5 ton all the way down to your 1.5 tons. Over 45,000, which this is where it can get tricky. Not all 4-ton units are 48,000 BTUs. Some 4-ton units really might run 44,500. That means they would have to meet a SEER rating of 14.3 under the new SEER 2 rule.
Gotcha.
If it's over 45,000, it is 13.8 SEER. So again, not making the dividing line at a 5-ton. I'm not sure how that came about, but that's how it came about. So now you got to really watch it, because it wouldn't apply to anything that is 45,000 or above.
Well, and I guess for those that don't know this, some listeners may not, the kind of basic rule of thumb is it's 12,000 BTU per ton. So, a 2-ton would be 24,000 BTU. And we always find that in the model number too. You've got for the most part, you can take, 12 times 2 is 24, and the model number will usually have a 24 somewhere in it.
Most manufacturers, and there's a few that don't, when you get the commercial equipment, then that doesn't apply to a lot. A lot of equipment won't. They have their own numbering system, and you need the nomenclature to actually know what it is.
Sure.
The one thing I did want to mention before we move on from FER ratings on these fan motors, many people complain about that ECM fan motor, even though it is more efficient at what it does because of the cost, and they feel they fail more often. Unfortunately, they will fail more often, and the reason is an ECM fan motor is made to push air at a certain rate, regardless of its RPM. A PSE fan motor runs at 1 RPM, period, regardless of how dirty the coil is, how many registers that the tenant or occupier has closed, so on and so forth. If you have dirty coils and registers closed or ductwork that's undersized with an ECM motor, then that ECM motor ramps up to try to push the same amount of air that it was programmed to push, which is typically 350 cubic feet per minute per ton. So if your unit was designed as a 2-ton to push 700 cubic feet per minute, or as far as 800 cubic feet per minute, with a PSC fan motor, if the coil is dirty and the ductwork's too small, you might get 600, but the fan motor will run at the same speed and it won't really affect the fan motor or its longevity. With a ECM fan motor, the fan motor will ramp up and work harder and harder to try and push the amount of air it's supposed to in an effort to reach the efficiency it's designed to get, which means now you're overtaxing that motor, which means it's going to fail prematurely.
Yeah, so that's something I didn't know, which that's awesome, and it makes me think about the importance of clean coils, clean filters, and registers open. I know some properties don't do regular filter changes. Some don't clean coils on the turn. those that do filter changes, I doubt you're walking through to make sure registers are open, because that's, the residents' first thing. They go close the one in the bathroom and the one in the closet so that it blows more in the bedroom.
Balancing registers to move air somewhere else is acceptable to a certain degree. Closing off, somebody's bedroom because they're not there actually is not saving them anything in terms of energy. The unit is going to run at the same pace no matter what. So it's not a good idea, especially in apartments where the ductwork is typically on the smaller side because of the constraints of the building. So the ductwork is always sized, toward the minimum in most cases. And you mentioned coil cleaning. Now more than ever with ECM fan motors, boy, if you can afford it or have the staff to do it on every turn or every renewal, which is what I did 20 years ago, it decreased the amount of service calls dramatically. I hate changing fan motors inside. It's a pain. It really is. I hate to do it. So, if I could have a guy who cleaned the coils and that kept me from changing fan motors, not only would I save a bunch of money, it'd save me a lot of heartache.
Yeah, so it sounds like if you're listening and you don't have an air filter maintenance program, I would absolutely put one in place for a whole bunch of reasons, but at the very least, $15 air filter is probably a lot easier to replace and a lot cheaper than a $500 fan motor.
It is, and it doesn't even need to be a $15 air filter, which is a whole nother. We could turn this podcast into a week-long discussion, but filters, especially in front draw air handlers or bottom draw air handlers, where there's just a single 1-inch filter. Your tenants or you yourselves could be shooting yourself in the foot by going and buying a MERV 11, MERV 13 filter. While it will remove more particulate from the air, it is very restrictive to airflow. To the case that if you have a regular residential unit with the space and you want that type of air filtration, it typically is in a 4-inch cartridge. Why? Because it has enough surface area to allow the air to move through at the proper rate. You go to any supply house and buy a MERV 13 filter and stick it in your unit, I guarantee you'll hear that fan motor, if it's an ECM fan motor, ramp up right away.
Do manufacturers recommend certain air filters for certain equipment sets?
They absolutely do. They'll tell you with a 1-inch filter that honestly, they don't want to see much past about MERV 8. They don't, because it's not designed, and they're not testing them under SEER 2 with MERV 13 filters in it, et cetera, et cetera. They're not doing that because that very small space to draw the air through is not enough to allow the air to come through if something's that dense. Whereas if you had a larger duct system with a large air cleaner with a large amount of surface area, then it could. But
okay. And so just to beat the dead horse, because this is one of the confusions that I hear from a lot of the listeners, a lot of people in the industry, the change to 14.3 SEER 2 will be the same refrigerant that we have now. It will be 410A for now.
It will be for now. And why we say for now is because A2L, which is a classification that the EPA started a couple years ago, refers to what we call a lightly flammable refrigerant. And people don't like to hear the word flammable.
Let's step into that. I've got like two more things on the SEER 2 change, and then we'll step into the refrigerant, because the SEER 2 thing is happening right now. I mean, we're already seeing the supply chain issues. I think the SEER 2 equipment is going to be available for purchase here pretty soon. A lot of listeners are thinking about their budget, right? So I'm already over budget in a given summer. They budget me for 8 units, I do 10. So previous years I'm over budget. Now with all the raw material increases, we've already blown that budget, not in number of units, but in dollars, because equipment is so much more expensive. Now we're talking about this shift to equipment that's even more expensive. What can I do to protect my budget at this point?
Again, unless you're planning on doing a wholesale replacement of all your equipment before the old equipment is no longer available, which is coming rapid. If you haven't done it at this point, you're probably not going to be able to do it, short of a large project, that somebody could come up with the material for. But
so, today I've got a 10-year-old system. Compressor goes out. I can either replace the compressor or replace the system. I think before all this changes, obviously the compressor is cheaper. If everything else is in good shape, I'd probably replace the compressor. Would it be better to get a current 14 SEER system now, brand new, and get it in there and know that you're good for a few years, or would it be better
I would say in the case of something major like a compressor on a 10-year-old system, yes, if your budget allows for you to go purchase today's 14 SEER, or remember, the 15, or in the case of above 45,000 BTU, 14 and a half SEER. But for most apartments, 3 ton and under is the order of the day. So on a 3 ton and under system, absolutely. Up until, and on the heat pump, again, we can still do 14 SEER after the first. It's just it's gonna be hard to find.
Yeah.
I know some manufacturers will ship them in here if there's a demand for it.
And so now, once we make the change to where the only equipment out there is SEER 2, whenever that is later this year, right? That's all going to depend on demand and, pent up supply. But let's say, September, all that you can get is a SEER 2 install. Same scenario, compressors out. Should I now just try to replace the compressor because that SEER 2 system is so much more expensive?
Well, that's really going to come down to the long-term plan for the ownership of the property. And if the property is owned and managed by the same people, the thinking sometimes different than when a property is fee managed, and there's two sides to that. Not one's good, not one's bad. You're still going to have to make that same decision. What conditions that unit in? If it's 10 years old and it's in good condition, it's a 410A unit. If it's a 22 unit or some mixture of some blend of something else, then you might as well get rid of it anyway. A 410A unit, and this is where, again, we'll talk about the A2L. The phase down, not phase out, but phase down of 410A is going to start pushing people and forcing people's hand on this. So today, if I have a 10-year-old unit, I can get a 14 and the price is still right and it makes sense, then I'm going to do it. Next month, if the pricing goes up 20%, and let's say an installation costs you $3,000, so now it's $3,600, that's going to hurt somebody's budget. There's no doubt about that. And it may force people to, rather than replace a 10-year-old unit, to repair that unit. So we saw this bump happen the last time, especially when we went from R22 to 410A. I mean, I can put a $400 compressor in this unit and call it a day and go on with my business, or I can go buy a brand new system and possibly have to change line sets, of course, flush line sets, all the things that we should be doing in conversion, or do I repair the unit? So I think we're going to see an increase in service, which it is difficult for the people on site, especially if they're doing their own air conditioning work, which, under Florida law, they're allowed to do their own air conditioning work. And it comes down to, they have a matter of time. You have how many work orders in a day? Do you have time to spend 4 hours changing a compressor? Or is it easier to call somebody to replace the system? It doesn't always come down to easy, it comes down to budget. So I'm not sure how the industry is going to react to that, but I would say you're going to need more good technicians. I think that's a given anyhow, across the board.
Yep. Okay, last thing, and then we can move on unless there's something else you want to cover. We know the equipment's going to get more expensive, but as far as the labor around the install, that the process itself really isn't changing. I know there's other things that are driving labor costs, but the equipment change itself, do we see that affecting labor costs?
No, not in the SEER rating change. The A2L, yes, there will be a labor cost difference amongst many other differences, but no, the overhead cost and the cost to do business in our current climate has gone up for everybody.
Yeah.
Doesn't matter what business you're in, you don't buy a Big Mac for $2 anymore. It's $5 or whatever it is. I mean,
do they do 50-cent cheeseburgers on Wednesdays anymore?
We lived off of 39 and 49-cent cheeseburgers when we were young, and no, that doesn't happen any longer. Inflation, so that's
okay. So I mean, that's probably the first of these changes. Not probably, it's definitely the first of these changes that we're going to see if you're not already seeing effects of it. Any final thoughts around that?
Well, and it does extend to packaged product. Again, in this particular industry, not as much of that, but there is ratings now. Package equipment is rated on EER, which is an energy efficiency ratio. So similar to those SEER, but EER. So there are changes there. I believe these graphics that you'll be able to share with people will help make sense of this, because we could talk in circles about all the minute changes across 3 different regions, and I talk about it every day, and it's still confusing anyway. So,
well, and I guess the other thing too for listeners to think about that we can't really touch on, because I think it changes from manufacturer to manufacturer, is the physical size of the equipment. I know when we went from 10 SEER to 13 to 14, some that replaced 10 SEER with 14 SEER equipment, the air handlers wouldn't fit in the closets anymore. We had people taking door jambs off to get air handlers in. So I know for some manufacturers that air handler size isn't changing. For some it is.
Some have had a problem since the last changeover and never overcame it. We use a majority of Carrier equipment in our business, and one of the reasons why is that the physical size of it, and the physical size for our 3-ton and under apartment styled equipment is going to remain much unchanged. The outdoor units can get slightly taller, maybe slightly wider, but not quite when we went from a very short unit to this 4-foot tall monster, and then thermostatic expansion valves, which is another discussion. Does it have a piston? Does it have a TXV in it? A TXV is far superior in performance, so to get these efficiency ratings, you can expect to see TXVs back into all the equipment probably from here on out. The piston will become probably a thing of past. Maybe you'll see it in some models and some you won't. And of course, this is a little more technical for people who may actually work on it versus those who don't. But it just means you have to be much more careful in how you charge these systems. Overcharging it with a TXV is much easier to accomplish than, say, with a piston. So
gotcha. And so I'd advise you to get with your local supplier on whatever equipment it is that you're using now, and see if you can find out, are they using the same model numbers for the air handlers? Is it a different model but the same size? Figure out the size thing now, so that when it's 100 degrees out and you've got an AC out, you're not trying to figure out how to cram an AC in a closet that doesn't fit.
From what I see, the nomenclature, the model numbers for almost all manufacturers is going to change.
Got it.
Just because when they make a change this large, there will still be some model numbers in the high efficiency equipment, an Infinity, a 17 SEER system, that won't change. Those units already will meet the SEER 2 rating anyway, so no need to make a change there. At least at the very beginning of the model number. There could be a series change, which is the numbers at the end of a model number.
Gotcha. Any final thoughts on the SEER 2? We good there? We want to move on to the...
Yeah, the only thought on that is we're doing this podcast for this reason. Rely on your contractors and your suppliers to give you more information. Obviously, Google's a big help. You Google SEER 2 and you could spend all evening reading about it. And and to a certain degree, people should get up to par on it. If they're purchasing large amounts of air conditioning services or air conditioning products, they should be aware of this, so they're not caught blindsided when their maintenance supervisor tells them they can't afford 10 this month, they can afford 8.
Yeah.
Because that's where it's headed.
Yeah, and so my intentions with this, Pat is absolutely the expert, but things vary in different parts of the country. Different localities have different permitting requirements. Different regions of the country have different SEER requirements. So my goal here is to make you think of the questions you need to ask. Go find your local professional and get the answers to those questions now, so that you're ready when we get into these changes.
Absolutely.
So I guess number 2, right? The next thing is the HFC phase down, right?
Correct. We all remember, at least those of us in the industry this long, remember the shift from R22 to 410A. Trade name Puron, which was a trade name put out there for our 410A, and there were others. That switch over was a big enough change for the industry, but not nearly what this change is going to be. This is going to be twice as confusing and twice as expensive and twice as difficult. It's really going to be a game changer. And for the industry, not for the good. For global warming, then maybe it is for the good, which is the reason they're pushing this change. We moved away from the R22 refrigerant because they decided that refrigerants that have chlorine in them were destroying the ozone.
The HCFC.
HCFCs and your CFCs, which was your R12s, R11s. So now we're really going back in time. But those were banned and completely phased out because they destroyed the ozone. So they came up with R410A, and they said, well, hey, it's great. It does run a higher pressure, but the system's really already designed to handle that much pressure, and it's safe, it's non-flammable, it's non-toxic, it's all these great things that, you know, the DOE and the government would like to see in a refrigerant. So they thought, that's great, 410 is the answer. Well, it had been for the last 20 years, and now they've decided that not just refrigerants, but many gases used throughout the world in the processes of manufacturing and the processes of air conditioning and refrigeration are causing global warming. So we've all heard of, you know, curtailing emissions from tailpipes and curtailing emissions from factories. Yeah, these refrigerants, again, if they didn't end up in the atmosphere, they wouldn't be a problem, but you got to realize that how stringent the United States, Canada, and Europe are in managing these refrigerants and recovering them and all that, and it's still not perfect. Unfortunately, the so-called developing world, which contains over 2 billion people, do not adhere to any of these standards, nor are they held to any of these standards. So they continue to this day, they continue to purge HCFCs and CFC refrigerants into the air. To this day, they're still doing it. Whole nother topic of discussion.
Yeah.
So, you know, for us here, we're bound and determined to meet these standards.
Yeah, and so I think the first thing I want to clarify that I think is shocking for some, when we talk about this HFC phase down, most people think 410A. Okay, 410A is going away. Well, first off, it's not a phase out like R22 was. It's a phase down. And second, it's not just 410A.
That's correct. Almost any refrigerant you see with an A at the end, 438A, 404A, 404B, 408, you know, azeotrope refrigerant. So anything that has what we call a GWP, which is global warming potential of over 750, will be either phased out or phased down. The reason 410A is a phase down is because there are other critical things that will still be on the market for years to come that will require that refrigerant. Air conditioning isn't one of those that they consider critical. It's not critical that we keep 410A in air conditioning if we have something else that has a lower GWP. So that's what we're pushing for and what the government has pushed for. And this starts in 2025.
Yeah. So for the multifamily industry, it's your 410As. It's your replacement refrigerants for R22, the 407Cs, the MO99s, you know, all of those. So almost every refrigerant we use in our industry now is part of this phase down.
Absolutely is, unless you do a lot of heavy refrigeration, which they've gone to CO2 systems. They've gone to using CO2, which runs at extremely high pressure, but that they have their own set of rules in the world of commercial refrigeration. But if you see them working behind your local Publix with trailers and job trailers back there, that's what they're doing. They're switching these equipments over to CO2-based equipment.
And so phase down, right? They basically tell us we can use less and less. I think this law, it's that the AIM Act was signed in 2021, and the goal was to get down to reduce 85% of the use in 15 years, so by 2036.
So the phase down, what will happen is because R22 was phased out, but during the time it was phased down first. They limit the amount the manufacturer is going to make. So what happens to the law and supply and demand? Okay, you can buy all the 410 equipment you want up into a point where they're going to cut it off, or what's going to happen is it's going to be too expensive for the manufacturers to produce and they'll quit producing it. Same thing. Are they coming out with a 410A replacement? They actually are. Is it going to be just like any other so-called drop-in replacement, which means you will lose up to 15% of your efficiency and up to 15% of your capacity? Efficiency isn't as big of an issue as the capacity is. If you have a unit on a second floor, third floor apartment that struggles already at a 2-ton and you replace it with refrigerant that gives 15% less capacity, now the unit is really struggling. Mm-hmm. But who is going to buy refrigerant that could be $1,000 a jug if some replacement is $400 a jug? So what's happening is they're starting this phase down, actually starts it actually started January 1st of this year.
That's right.
Which is part of the reason that 410A went up in price. A lot of people thought it was just inflation. Well, it was more than that. It's because they actually phased down. They said, okay, manufacturers, we're limiting the amount that can be brought into the United States of America. Now, just like with 410A and R22, will people illegally believe it? You think they smuggle drugs in here to make money? They smuggle refrigerant into this country, and they just recently did catch somebody doing it because they can avoid all sorts of taxes and things like that. So the reason that they are going to keep a little bit of the 410A, though, is just like myself, I occasionally have asthma. I have an asthma inhaler. That actually has a propellant in it, 134A. 134A is also part of this phase down. So what is in your cars, what is in your refrigerators, if you have a newer vehicle, you probably have R32 in your air conditioner anyway, or you may have propane or isobutane. If you have a new refrigerator in your home, I'd almost guarantee you have isobutane or propane in your refrigerator.
Yeah, we'll cover that in the next section because I guarantee that most of the listeners have already felt that pain around ice makers. But we'll get to that. So the first part of the phase down is this year, 2022, and next year, 2023, is 90%. So 90% of what they've made in previous years is what we can bring in this year.
Yeah, and the big turn, really, if you look at the graph that's available, you will see that 2023, 2024, when it switches over there, it's a big chunk, another big chunk, and that's when you can really expect the prices to start rising quite a bit. Hence, the manufacturers are all going to start bringing this stuff to market. Many of them already are, and actually, we'll get into this, but Florida is one of only 4 states that actually has code on the books to install A2L refrigerant equipment. The rest of the country will have to quickly work to updating their code books to meet these requirements because people will have no choice other than to install an A2L system.
And the A2L is what will be the replacement for these 410As when it goes away. But like I said, I think we step into that in the next one. I want to just focus on the phase down itself because we're already seeing the price of 410A and all those other replacement, the drop-ins for R22 climbing. And a lot of people are like, well, I mean, it's only a 10% cut. I think what people fail to factor in is that today we are still replacing R22 equipment with 410A equipment. So we're adding more equipment to a already lower supply. That's driving the price now. Continue that for another next year. So some people are like, oh, well, next year's the same as this year. Well, you're going to feel it a little more because you're adding more demand in new equipment, and we still don't have enough supply.
You hit the nail right on the head there. This is actually the price escalation of this refrigerant and the equipment will probably be 2 times what it was when you went from 22 to 410 for that very reason. You have a larger installed base, as we call it in this industry. Look here in the Southeast, we're still building thousands of apartments and homes every single day in the state of Florida, and they're all 410A. You don't think there's going to be a demand for all the, so the base is continuing to get larger through this entire year, through the next couple of years, yet the amount of the supply is going to shrink. So forward-thinking developers and builders will start looking at putting in A2L equipment for this very reason, because it's long-term it may be a better solution for them. Yeah,
and so, I mean, like I said, we're already feeling it now. I think even though the phase down doesn't change percentage-wise next year, we're going to feel it even more next year. And then, like you said, 2024, it jumps down to 60%. That's a massive. I mean, if we're feeling 10%, we're going to drop another 30.
I think that's when it really hits the fan, so to speak.
So, I mean, I think the place that most listeners are going to go first is, let me stock up on some of this stuff. How good of an idea is that?
It's like playing in the commodities market. As a large company, we do it to a degree, like copper. When we foresee copper prices escalating, we may go and purchase copper, refrigerant, absolutely. I mean, I still have R22 refrigerant because there are some specialized pieces of equipment still running on R22. I have a production chiller here at a pharmaceutical factory that runs on it, and to replace that production chiller is hundreds of thousands of dollars. They'd rather buy the refrigerant even if it's $1,500 a jug.
Well, and I mean, obviously, this is your industry, is what you guys do, so you have some proper storage for that. We're talking about a multifamily, a complex with garages. How many jugs could I really store in a garage before I'm doing something I really shouldn't be doing?
Well, and that's a good point, because probably you're not going to, unless you have some big specialized place to warehouse this, you probably couldn't buy enough to curtail your cost increase. You probably couldn't, not as an apartment complex. It'd be very difficult to do so. And then you have to worry about, of course, like any inventory, shrinkage, or where did it go, or got lost, or got misused, or no. So it's a liability to keep that much product on hand without a really good inventory system. And some people have really good inventory systems, so it may not be as big of an issue.
Well, yeah, at $1,000 a jug, the stuff will grow legs and walk away.
And we'll see a peak in the price of it, and then as things change, then you'll see it drop off again. We saw that happen with R22. The price skyrocketed, and then the price had tapered off because of all the so-called replacement refrigerants.
So part of the increase in demand we're seeing in those additional units, I mean, they're all pre-charged. So some of this allotment is going into these new units that are going to be installed. Do you think we'll start to see dry units again, so that it's now on the end user to source the refrigerant? And
you may very well see that from some manufacturers, and some, I can tell you won't see it. But I can tell you this, that's already been commonplace in the last 3 to 4 years in commercial equipment. 7.5 ton, 10-ton split systems from manufacturers such as Trane, most times come empty, because for them to price their equipment and put it on the market and have the refrigerant inside of it be volatile in price and go up and down in value hurts them. If the refrigerant cost goes up and they've priced the unit at a certain price point, now they're taking a beating. So it's going to be difficult.
I assume that they're working on replacement refrigerants for 410A. I know today there isn't one that you could buy, or at least that our listeners could buy. There might be one that's commercially available on a larger scale.
The big trick with that is it's going to have to meet the GWP requirements. We're talking GWPs under 750, and then eventually less than 150. We're talking about over the course of time. So what's going to happen is, if you produce some sort of refrigerant you say is a replacement for 410, it's going to have to meet that GWP requirement, or they're not going to allow it to be produced anyway. Mm-hmm. And again, I've been reading up on one in particular that they believe is going to work, but they've already said right out of the gate, it's not a drop-in. You may have oil return issues with a compressor, which mean it may smoke the compressor. That's a fancy way of saying that. And you're going to lose efficiency, and you are going to lose capacity, which is the big one. You're going to lose capacity. The unit won't do as much cooling as it did before. Will it still run? Yes. But when it's 100 degrees in Jacksonville, that's when you get your service calls. And nobody wants to hear that their unit's just not big enough to do the job. Yeah. They all pay the same rent. They don't want to hear that. So.
Well, and so I guess the biggest takeaways here is that, the price increase that we're seeing now is going to continue, and more than likely going to get worse as that function of supply and demand. But the other piece of it too is, as they continue to make less, you might get to a point where you can't find it.
That's where it's headed. I mean, ultimately that's what a phase down is. It will make it so expensive to use the refrigerant that people won't. And then in the case of a replacement, again, the replacement may be quite expensive itself. We have no idea at this point. And remember, these are federal laws. Every state can enact their own measures that can be more stringent, not less stringent, but more stringent. In the case of California, in some cases Florida, they already have and already will. You may find bans on these types of refrigerants. I mean, in California, they've almost already said that they're going to do it. How you control that, God, I don't know. You can't stop things from coming across the border. Now you're going to have to worry about refrigerant coming across the border. I don't know. It's going to be difficult.
Well, and I think one of the benefits to the phase down and ultimate phase out of R22 was that once that started, we had a new equipment with a new refrigerant. So as they got to producing less gas, we could be installing equipment that used a different gas. So the demand is coming down with it. right now we're already phasing down, and there isn't a new equipment available with a different gas right now.
No, and it will be shortly, though. Okay. A2L equipment will be more commonplace by the end of the year. Only in the states that have it on code, but the rest of the states will have to get up to speed and get it in their code books for the simple fact, if you're looking at replacing a unit and you're looking at a 410A unit, that is not really a long-term viable solution anymore, and there's an A2L refrigerant type unit available, the price point is what's going to push people one way or the other. If it's double to go to an A2L unit, then no, they're going to stick with 410 until the cows come home, until they're forced to do something else. If the price point becomes fairly comparable, then people will be wise to abandon the 410A equipment. But the A2L refrigerants pose many, many changes.
Yeah, so this is kind of where we step from equipment needing to get more and more efficient to the gases needing to be, safer, I guess, so to speak, less global warming potential, better for the environment. It kind of brings us to the third point where we go to this new class of gas, and not necessarily new, but new to comfort cooling, new to AC, and in this in our world, in the multifamily world, that A2L talks about basically they're low toxic, mildly flammable gases. Right?
Yes. Mildly flammable. So what that means is, unlike back to refrigerators that have propane in it, propane is extremely flammable and can be extremely dangerous as a refrigerant, which is why you're not required to recover the propane out of a refrigerator when disposing of it, like you were required to do so when it had 134A or 22 back in the day. They don't want you to mess with that, and it's in a sealed system, and they claim that the 5 ounces of it in there can't cause a catastrophe. The jury's still out on that, but be that as it may, that's where we're going. R32 and 454B are the two leading replacement A2L refrigerants that are on the market. The possible drop-in, by the way, is 466 is the number for that one. If anybody wants to look that one up and start reading about it, that's the possible drop-in, or so-called drop-in. But this A2L refrigerant, so what it means is, under certain circumstances and certain situations, it could become flammable or explosive. So do we want to circulate 13 pounds of that through a coil inside of a house? The answer is no, we really don't. But now there's no choice. So what that means is to ensure that you never reach a situation where a leak would cause a catastrophe, there's going to be all sorts of new regulations and requirements for installing and servicing this equipment. The EPA decided not to recertify technicians. In other words, if you have your EPA card, initially they wanted everybody to get a new EPA card, which of course means more money for them, so on and so forth. Well, that didn't happen. The industry fought that off. If you've taken the test for your EPA card a long time ago and looked at it now, it's completely different. It's changed. The program has changed drastically, and they've had to add all this about A2L refrigerants in there. The training that is going to be required for your average technician working on this stuff, who has never dealt with it, knows nothing about it, is going to be steep. The learning curve is going to be extremely steep. You're going to be required new vacuum pumps, new recovery machines, new sets of gauges. You're going to require all sorts of new equipment to work with this refrigerant, and there's all sorts of guidelines and restrictions on how it can be applied and where, which is probably one of the most concerning things for the apartment industry itself, because we typically end up with small tonnage units that can have extraordinary long line sets. That normally is not an issue, but in the case of A2L it is, because in these codes there is a limit to how much refrigerant a system can have in it. So a 2-ton system shipping an A2L unit shipping with the refrigerant in it will meet that code requirement up to only a certain amount of feet of line. What if your line set is 150 feet long? How much more refrigerant do you have to add to overcome the line size? That may push you beyond the amount of the refrigerant allowed. So in that case, what would an apartment do? They would be required to put forced outdoor air ventilation into that closet that would turn on, basically, if there is a leak sensed. The cost of installing a fresh air evacuation system in a closet in an apartment complex is going to be probably as much or more than the air conditioner. So we're talking potentially doubling the cost of air conditioning.
So let me break it down, right? So the idea is that, you know, the mildly flammable refrigerants in the right concentration are flammable. And so the idea is if we don't allow a certain amount of refrigerant into the system, that if it all were to leak into that apartment, you wouldn't have the concentration. So it's the idea. There's a chart that talks
correct.
about.
It's based on square footage.
Yeah.
Free area. So if it's a 800 square foot apartment, the code is going to say there's X amount of ounces of refrigerant allowed in this system installed in this. Who's going to regulate and certify all this? City of Jacksonville is probably going to have to hire a whole lot more code inspectors, I guess. I don't know. I'm not sure how that's going to take place, because if it's not done correctly, you could create a potentially dangerous situation.
So, yeah, that's where we talk about, you know, it's not just, you know, the system won't function right or it won't cool properly. I mean, if you put too large of a system, you know, in terms of refrigerant into too small of an apartment and it does all leak, I mean, we may have a problem.
We could seriously have a problem, absolutely. You're talking fires and explosions. So this is serious, serious business. And where this also leads to is even on the service and not just the installation. Okay, we all know in our business when you braze new lines onto a unit or change a dryer, you are supposed to purge the lines with nitrogen. You're not supposed to be brazing with refrigerant in the lines because it turns to ash and causes problems in the system. I see it done every day though. Mm-hmm. Okay, now you're going to put a torch that's 1200 degrees onto a piece of copper that has a flammable refrigerant in it and oil. I don't think that ends well. So this is back to training. People are going to have to purge systems with nitrogen before they do anything to them. Doing leak searches is going to change. You may not want a halide leak detector that generates heat when you're working with a flammable refrigerant. And it probably wouldn't pick it up anyway. So
Yeah.
Again, back to new equipment, it's going to cost the technicians and of course the people in the industry an extraordinary amount of money to make this change over.
Yeah, so I mean, I guess the first thing and kind of the analogy that I'll use, because we're already seeing it, is where it comes to refrigerators. I know there's certain refrigerators now that customers are struggling to find ice makers for, because they changed to this A2L refrigerant, and now you could no longer use the traditional ice maker because it may create a spark. And so you basically had to go to these, I call it explosive proofs from the military, but it's basically something that could never create a spark. We're going to see the same thing in your inside and outside unit.
That is the reason for the cost increase. So now you're getting a cost increase because of the SEER rating going up. It's a more efficient piece of equipment. Exactly what you just said. You have a refrigerant that is potentially explosive. Now you have to have explosion-proof motors, which cost twice the price of a regular open-faced motor. They are going to be required to put refrigerant sensors inside the air handler and in the outdoor unit that will shut the system down in the case of a leak. So think about your own leak detector if you have one, in the $200, $300, $400, $500 you paid for it. You're now talking about putting those components themselves into every single air handler that comes out in production. Because if it senses a leak of that refrigerant, it's required to shut it down. And in the case of square footage meeting the requirement, it's required to start a ventilation system. In the case of commercial equipment, it's required to start a pump down cycle, which is a cycle where it stores a refrigerant in the outdoor unit. So you're talking about adding, you see a little tiny circuit board in your equipment now, you're going to see a full-fledged circuit board like what we'd have in our very high-end equipment that has, you know, actual logic and algorithms and every, you know, a small computer.
Brain. Yeah.
Exactly. It's intelligent. It's going to be in every piece of equipment coming out. So the cost is going to, it's going to be a lot.
Yeah, I mean, so think about opening your air handler or your condenser now. You know, every circuit board, every electronic in there is going to get, you know, more expensive because it needs to not be able to create a spark.
Much bigger, much more complex.
And then the addition of that leak detection system, which is additional equipment that isn't even there now, and the nature of that equipment is that it's kind of silly expensive.
And this is where it's going. It's going to change our industry like we've never seen before. Manufacturers making compressors and units, in a factory for a refrigerator is one thing. That's a controlled environment. Now we're talking about field installed, field built up systems where technicians are handling this refrigerant on their own, and to be applying all the lessons that they're going to learn on this. And what's going to happen is the potentially dangerous situation of people being asked to work on air conditioning equipment who are not qualified. With a 410A or an R22 unit, you probably weren't going to burn down a house or blow up an apartment if you did something wrong. You might ruin the system, but you were probably not going to kill anybody. That will no longer be the case.
Yeah.
This liability, and I don't know what this does to the insurance industry. There are so many questions. Yeah, there's so many ramifications of this. I don't know.
Well, and so I'll back it up. Pretty early on, I was going to circle back to it. You said that the EPA decided not to recertify, retrain people with existing licenses, which is, it's great. You can still buy the refrigerant, but personally, there's so many changes here. I would highly recommend taking the class again anyways, whether they require it or not. Learn what's changed there, and all the way down to the technician type training, the do's and don'ts. Just because it's not required doesn't mean it isn't necessary. It isn't something you should do.
Well, and that dovetails into talking about training. See, the EPA course and the little bit of training you can get on your own, or a little bit of we do a review here to help people pass the test, and bring them up to snuff. That's not going to be able to take the place of a full-on training session. My own people are going to be required, and this is where it's different, and it may become an issue. Most of the manufacturers are going to require you to have a certification from them, or a separate certification for A2L refrigerant, before they will even sell it to you.
That makes sense.
This may be a problem where somebody who is not a contractor or is buying equipment directly from a manufacturer, or even in the case of somebody who sells equipment on a wholesale basis, is going to find that they cannot sell that equipment to somebody who doesn't have the training, or at least somebody on the staff has the training.
Well, that makes a whole lot of sense, because we see it today. You'll have that one property with the one maintenance guy that, he's installed 5 systems in a row, and all 5 of them suddenly have bad compressors. You're not the most unlucky guy in the world, and you got 5 condensers with bad compressors in them. You probably didn't do the install properly. If you were to get one of these A2L systems and not install it properly, and something happen, the manufacturer needs some kind of card to wave to say, hey, the system was good, it was the install, and that's probably that certification.
That's where some of the jury is still out on some of this. The EPA is still trying to determine some of this stuff, but they've also really pushed it to the industry and said, look, we have an EPA program to tell you about all this and give you enough information to get a card which allows you to buy refrigerant, handle refrigerant, transfer refrigerant. That's all that card is for. It gives you no license to do air conditioning work or anything. It's just a card that you're required to have to buy refrigerant because the federal government says so. Local municipalities and states may decline permitting for this if you don't have possibly a state license. Well, they may decline. Right now, you can't install a whole system without a state license anyway because of permitting, but in municipalities where they do, like Texas and places like that where they do, that will come to a screeching halt most likely, and then the states can enact their own requirements, but the manufacturers are the ones who are going to drive this. Again, I speak a carrier because I use a lot of their product and have a relationship with them for the last 35 years, and flat out, they're not going to sell this equipment to people who do not have a certification to use it and the training to use it because of these liabilities that we're talking about.
Well, I take it one step further, right? So whether it's required or not, whoever requires it or doesn't, if you're the technician that's installing, personally, I would want something I can waive, a class of certification saying that I know what I'm doing. So if a unit does blow up, I can say, hey, it wasn't me, it was the equipment. I know what I'm doing, I'm certified. Those sorts of things. I think a lot of the training in the industry that should happen a lot of times doesn't, and I think this is one of those times where that cannot be allowed.
And even in the case of service, not just the installation, let's get it for instance, you talk about explosion-proof fan motors. They cost a lot of money. What if the fan motor goes on a unit and you ran down to your local parts store and bought one that goes in an old 410A unit, and it happens to fit into the new unit you have, and you stick it in there, and it's not explosion proof. Runs fine and everything's good until the day you have a leak in the coil and something happens. So there's a lot of ramifications and a lot of inherent dangers with this. Fortunately, the refrigerant is very hard to combust. It really is. If you watch some of the video, and there's information again on the internet on this already, and I've already been to training classes twice on it, and it would be hard to get this stuff to combust. But can it? Absolutely.
Well, that's true. I guess we need to be clear. What we're talking about is worst case scenario here. It isn't a system running on straight propane like your barbecue grill or something like that.
No.
It is hard to, but in the event that it does, we want to make sure that everyone is covered, because, I mean, you're talking about life here.
Well, A2L refrigerants have been in use for many years now, especially in Asia. Most of your mini split equipment out there is using R32 right now. Most of it is. Still can buy much of it in 410A, but a lot of it is being used and has been used with R32. Good news with mini split systems, they contain less refrigerant than a full-blown air conditioning system for a building such as this, or a home or an apartment. So there's some ups to that, but it's nothing new, and so the standards are out there, and the practices, best practices are out there.
We see them a little bit now. They have these flame-free fittings for the copper. They're like push-to-connect fittings. You don't need to use a torch at all for the install. They're not, they're used, but they're not universally used at this point. Do you think that the flammable refrigerants will drive more use of that type of an install instead of a torch?
I believe it may, especially in the case on the new construction and where there's multiple systems at a time. But even on a service end, if a guy had to change a dryer out and all the protocols to go along with this refrigerant, you would be able to not circumvent, but have to apply these protocols when you're using that type of fitting. I can see a market for that. And in some cases, especially inside apartments where brazing is already an issue inside an apartment, setting off smoke detectors. It's already
sprinkler
an issue.
systems.
Yeah.
I've seen plenty of flooded units because of the sprinkler head in the air handler.
It happens all too often, and in the case of saving $10 because you brazed the joint instead of using a fitting that didn't require brazing. The fittings have gotten better. Early on, they were still prone to leakage, but some of the newer ones out have gotten a pretty good track record. I mean, so I think that's I think it is, and I think the industry producing those fittings is going to grow. If I had to bet my money on it, I'd bet.
And then something else I want to touch on. I know you mentioned it, but I want to hammer it home. And we talked about the change of the equipment in the units to become explosive proof, basically, and that applies to all your tools. You said, the gauges, the vacuum pumps, the recovery machines, all of those are going to have to be of the type that can't create a spark either. And so we're going to have this massive change out where, the EPA requires you to have that equipment on site. And so not only do you have to have it, but now you're going to need to have, the proper type for the refrigerant that you have.
And be trained to use it. That's the other thing. Many, other than formal education in this industry, a lot of people, myself included, you learned from other people who'd been doing it. And that was great because you were working with something they were very familiar with and had been doing for, 20, 25 years themselves. In this case, it's as new to me as it is to you. And I've been doing this my entire life, and this is all new to me. So it's not like we can just hand down this knowledge. There is going to be a requirement for training. I'm sure that the FCAA here in Jacksonville is going to be addressing that coming forward and offering, I would assume, some sort of training for this. We haven't really discussed that at length, but not just from us, manufacturers, other supply houses. I mean, I think the industry is going to really be putting it out there, and people are going to have to take advantage and get involved in it. This isn't a training that you can say, I don't need that, I'm the smartest guy in the room. Look, I've been doing it my whole life, and I've done nothing but train on this since the word came out.
So the smartest guy in the room would be in that room because he knows that he needs to know everything he possibly can.
No doubt about it.
I think it's important to note too. So one of the confusions we see is, the kind of three topics we just talked about are happening separately. So this new SEER 2, 14.3 SEER 2 is not coming with this mildly flammable refrigerant in it. It's separate. Immediately we'll see the change to the 14.3 SEER 2. Currently, and while that's happening, we'll see the phase down of the R410A and some of those other replacement refrigerants. And then in the near future, we'll see this A2L changed. Any idea when we will start to see this equipment?
The equipment will already be on the streets as of September. Okay,
Oh, wow.
so it's already going to be available. And I can tell you the first place they'll aim this at is the higher end equipment market. Okay, so if you're buying a very high end, say, infinity system for your home, or business or wherever you're buying this thing, that equipment, because people are already used to spending much more for an air conditioner to buy this high-end type of equipment, that will be the place you'll see the change come first and foremost, is on the high-end market stuff. Because, again, the people in that market will pay the additional cost for it anyway, and those people typically want the cutting edge. They're not going to buy a $15,000 air conditioner for their home and buy something that will be outdated in 2 more years. 2025 seems to be the linchpin for this, where most manufacturers are going to start abandoning 410A equipment altogether and putting out their own version of A2L, whether it is R32 or 454B. And there may be others coming, but those are the 2 odds-on favorites, because the 2 largest manufacturers in the world are the ones using those particular refrigerants. So the rest of the industry usually follows suit.
So there's 2 things I want to mention there. So first, I think it's important to note that most of the AC equipment manufacturers, they're not struggling to figure out how to make this stuff. They're already making it for other parts of the world for the most part. It's a matter of bringing it here, and I think a lot of that is a legislation issue, right? You touched on the fact that there's only a handful of states that even allow this refrigerant in these systems today.
That's a lot of it. It's in use worldwide, and again, back to Asia. Well, if you go to Asia and much of Europe, it isn't like here in the United States, where almost every building in the last 50 years is built with air conditioning. Add-on air conditioning still happens in some parts of the country, but not most places. It's a replacement. Here in Florida, there's very few things that were ever built, unless you're going back to the 40s or something, that were built without air conditioning. So it's different. The manufacturers know how to make it, and the industry has learned how to deal with it on a smaller scale, which is mini split type equipment. It's a different animal, even though it can be split equipment. We're talking about full-blown systems, 5-ton, 4-ton systems going in homes, which are large split systems, and the amount of refrigerant, that's the real game changer. Again, back to the refrigerator, it's got propane in it. It's a small amount, so they get away with not having to have all sorts of standards in place, whereas this, where you could potentially fill a room up with this gas, there's going to be a lot more to overcome as far as the installation. The manufacturers have had to, again, now put sensors in there. There's no sensor in your refrigerator for that when it's leaking. It's a small amount. They don't feel it could be catastrophic. In this case, that's not going to be the issue. They have to, and the manufacturers know what they need to do with it. It's explaining to the public why this equipment is going to cost more, especially initially, as the manufacturers, the contractors, the distributors absorb the cost of doing this type of business, because it's completely changing the industry.
And massive amounts of training. I think so. In terms of the timeline, right? So it's 2024 that we get to 60% on the 410A phase down. I think to get to that point in the year and not have a different type of equipment, the demand is going to far exceed the supply.
And that's where the manufacturers play it by ear to a degree. And let me tell you that this stuff goes hand in hand, even though they're separate issues. And the manufacturers see that. They see, 2024, the price is going to really escalate on this. We would like to have something for the consumer to go to, and that's when I'm talking about the price point. If at the end of this year I came and told you I could put a 410 in for $3,000, but I could put an A2L in for $4,500, you'd say, give me the 410 unit. I don't want that. Mm-hmm. But once the price point becomes where there's not a whole lot of difference, which is how 410A eventually overtook R22.
Yep.
People buying a new system said, well, wait a minute, why would I buy an R22 system when a 410A system costs the same and 22s being banned. That's what's going to happen with the A2L. Eventually the 410A, which is part of the phase down, will become so expensive and in such short supply because, as you touched on earlier, the base has just gotten enormous compared to the R22 base that we had to replace. This base is probably double in size of what it was. So the effects are going to happen much quicker. And I think at that point, when you hit that linchpin, that's when the manufacturers will bail. They will absolutely bail, other than specialty equipment. They'll still make replacement parts for a lot of this stuff, of course, but as far as brand new systems, 2024 is going to be the start. At 2025 may be the turning point where it won't make sense to use 410 anymore. And you're talking 2 years down the road, basically 2.5 years down the road, so it's coming quickly.
Yeah, so I mean, in terms of, how does this impact me on site right now, I'd say, there's really nothing you can do other than be aware of it, be aware that it's coming. It's not going to affect this year's budget. This is not affecting next year's budget. But whenever it does come, it is going to be something that affects the budget, especially if you're one that needs that extra ventilation in a unit. It's just like we talked about on the 14.3 SEER 2, trying to find out if that new equipment, for whatever brand you use, is still going to fit in your closet. It's a similar thing here. That's a question you're going to want to ask early on. Can I install the units? What additional things will I need as part of that install?
No doubt, and we have no guarantee on what the size of the A2L equipment is going to be at this point.
That's a whole different question.
It is, and the manufacturers are keenly aware of this. Manufacturers are very aware of what the existing footprints are, and in all cases, they do the best. In the world of commercial equipment, they try to manufacture equipment that'll actually replace somebody else's equipment with the same footprint, just for that reason. So you're going to see a lot of that's going to happen. But your cost escalation has already started. Your cost escalation on this by year's end, when A2L goes into effect, it is real. So your next year's budget, if you're not already planning for it, you are going to have a problem. I mean, to say it's 20% more after January 1st to put in a unit, hopefully it isn't, but that's not far-fetched by any stretch of the imagination.
Yeah, I mean, so it's July. We're filming now. I mean, we're 2 months out from budget season in most places. September-ish is, give or take. That's when we start budget planning. And so, think about the increases of 410A. You're going to be paying more to get the same refrigerant more than likely next year. Think about maybe stockpiling a little, work a little extra into the budget to get an extra jug or two. Buy a jug when you open the last one, not when you run out of the one you're on. I'm not saying get a pallet and put it in the garage. There's a lot of reasons why that's probably not a great idea, but the old maintenance mentality of I'm out, let me get another, it'll be here tomorrow. It might not be here tomorrow, and it's probably going to cost more money. So,
well, but in that sense, if you have the capacity to get extra refrigerant now, I don't think you're going to lose money on it.
Yeah, I agree.
If you bought a jug for $300 today, I don't think 6 months from now you're going to get it for $250. I don't think that's going to happen. That bubble, that rise, and that fall again, that fall won't happen until A2L becomes prominent. And speaking to that again in refrigerant terms, new A2L system. You want to have some A2L refrigerant on your property to charge a system that has developed a leak? Now you have to worry about storing something that is lightly flammable. So now the game has changed. You may not be able to go to an unconditioned maintenance shed and store 15 jugs of refrigerant. There's already issues with actually doing it with today's refrigerant, but it's an issue for me in my business because I do have pallets of refrigerant. I have to.
Sure.
But
I hadn't thought of that. Yeah.
For me to store pallets of something that is mildly flammable, they've already said, and again, this is back to codes and everything else, and this is now where fire code comes into play. They've already said that it's going to have to be a certain amount of ventilation per square footage. It's going to have to be in locked storage. There's all sorts of rules coming to the actual storing of this refrigerant.
What's refrigerant today? Is it a 20-pound jug?
Roughly? Your 410As are 25, and then the 22s were always 30s.
Yeah, so, I mean, you think they'll go to a smaller jug that, or
they're going to be all different sizes. Again, you can buy 410A in very large cylinders too. I mean,
and that's fine.
There'll be all sorts, but I'm going to tell you.
If I got two, 25-pound jugs of A2L in the shop, that's potentially 50 pounds of refrigerant in my shop. That wouldn't fit that chart. for being allowed without some sort of
ventilation.
Exactly.
Yes, and this is where actually in EPA code there are already some of this for rates of ventilation, ASHRAE standards that are going to be applied, and people aren't going to think about this. But as you said, you store 50 pounds of a flammable refrigerant in there and there's no ventilation, you may not meet fire code at that point, and the fire marshal can come and say, nope, sorry, get that stuff off of this property, we're shutting you down. I mean, I don't know.
Well, and I'd look at new construction. I mean, I personally did a new construction property when I was on the maintenance side. Obviously we see tons of them going up. A lot of times the maintenance shop is an afterthought. I've been on new construction sites where they take a garage and turn it into a maintenance shop. I would say with this coming, if you're listening and you're getting into new construction, I would plan for this in your maintenance shop design, plan some sort of positive ventilation. There's some maintenance shops that aren't even air conditioned, let alone, externally ventilated.
Most of them aren't, and even if they have a small, PTAC or whatever they may have in there for cooling, they're probably going to have exhaust equipment.
Oh.
And if they're storing this refrigerant, it will require a refrigerant monitoring sensor, which is now we're getting back to ASHRAE standards that are already in existence, that will automatically turn on a ventilation system. So, in talking with the city and state officials, they're still trying to figure out how they're going to enforce this and keep track of it. Because inevitably what's going to happen, inherently this refrigerant is going to be safe when it's applied and used correctly. Otherwise they wouldn't be doing it.
Absolutely.
It's going to be, the problem is going to be the people who go outside the norms. With 410A and R22, we didn't worry about things exploding or things catching on fire so much, or somebody killing somebody because of their own negligence or lack of training or stupidity, whatever you want to call it. In this case, an unassuming person who doesn't have the training says, yeah, I need a couple jugs of that, puts it into a maintenance shop that maybe gets 120 degrees over the weekend when nobody's there, and potentially a problem. So now the fire marshal is going to, I don't see how they don't get involved with this. I really don't. And it may take somebody's building blowing up before they do. I don't know.
Well, and I'd say then you get an inspector in your maintenance shop looking at that. I would make sure your maintenance shop's up to snuff on everything else, because when they come in, they start looking around. Where's your flam locker? Where's your IWAS station? I mean, this is a whole different can of worms. And then I would say, as a rule of thumb, if you're listening and you still operate based on beer can cold on your AC, you probably shouldn't touch A2L ever.
You probably shouldn't touch anything with a TXV ever. That's what happens. The beer can cold thing was never correct, but with refrigerant lines that are exceedingly long, when you overcharge a system with a piston, it more or less stores the refrigerant in the line set, which means that the apartment doesn't get the cooling power it should. But will it still cool? Will the line still be cold? Yes. The issue with the thermostatic expansion valve is, as you continue to overcharge the unit, the thermostatic expansion valve continues to fight you. Trust me, all these A2L systems more than likely will be TXV. In fact, almost all these 14.3 SEER 2 units are same boat, TXV. So learn proper charging procedures. Again, training. Fortunately, electronic gauges and all the tools that you guys have these days that I didn't have, doesn't mean you still don't learn the right way, but there's less of an excuse for not doing it the right way.
Yeah. Well, I mean, Pat, any final thoughts? Anything that we didn't touch on that you'd like to?
Not really. Again, it's a kind of a boring topic for a lot of people. I get it. It's an extremely important topic for our industry, and of course, for any construction or management industry, it's going to be an important one because of the inherent dangers that may be coming, and of course the cost. That's the big one that's going to get everybody. Following through and what training will be available and afforded and offered by who is probably be a big question coming into next year. People will have to start preparing for this. We keep saying 2025, it's a little closer than you think it is. So people have to start thinking about that. And information like this podcast, that's why I'm here today. I'm just trying to sound the horn so nobody, at least my customers in our local industry, can't say, well, nobody said anything about this. Well, I believe we are. We're trying to say it right now
That's
because
it.
it's such a big change.
Well, I know a lot of listeners bonus based on their budget, so proper planning will help you to still hit that if possible. And I'd say the other thing I just thought of while you were saying that is one of the things I would budget for this year is additional training dollars for next year.
Absolutely. I agree.
Awesome. Well, Pat, I know summer in Florida. I really appreciate you taking some time to sit down with me because I know it's this is the busiest of the busy season. So I appreciate it. I hope we brought some value to the listeners, and maybe we can do it again on something a little less so costly.
It may be about the training.
Awesome. Thank you, Pat.
Hey, my pleasure.